Hello, wonderful physics students. This is your leader here, Captain Rod, and I'm going to talk to you a little bit about how to do some of the problems on your Unit 1 homework. Okay, so I'm going to take a look at, I'm going to start this with number 3, where it says, let's see, a passenger jet flies from one point to another, 13, well, the one I have says 1,333 miles away in a speed, or in 2.7 hours, find the average speed. So, all right, velocity, remember, is delta x over delta t, or it can be delta y over delta t. It's or delta z over delta t. Whatever you call this here, that's just some change in position. And velocity is related to speed. All right, when you calculate your speed, right, that's equal to distance over time. All right, and this one's what's called a vector quantity. This one's not a vector quantity. Your speed is basically how fast you're moving. And this question specifically asks about speed. So take the distance given, and it's given in miles, and divide by the time in hours, and you'll get a number with units of miles per hour. And that's all there is to number 3. All right, number 4, very, very similar, really. It says, what is the runner's average speed? So they give you a couple mile markers. On mine it says the 9-mile mark, and then it says later on it says the 17-mile mark. The difference between those is going to tell you your distance, and then just take the difference between the times. So mine says 9 miles at 1 o'clock and 17 miles at 3 o'clock. So the delta t in my example is 2 hours. Yours will likely be different, but basically same thing. You're just going to calculate, take your distance traveled, divide by time, get your average speed. Okay, number 5 in the homework, basically the same thing. A lot of these problems are almost repeats here. So in number 5, it says a car going 27 meter per second. Oh, I'm sorry. It says, how does a car traveling at 27 meter per second travel in 6 seconds? How far would a jet going under 95 meter per second travel in 6 seconds? So number 5 has two different things going on here. We have a car and a jet. And there's a speed given for the car. In my example, it's 27 meter per second. Yours probably is a different number. Then there's a time, 6 seconds. Again, in mine, yours may be different. And then a jet, in my example, 195 meter per second, and again, a 6-second time frame. So it says how far. So we're given speeds and times, so formula-wise, you're going to want to start here. And it says to calculate how far. Now that's an unknown distance. So I'm going to write it like this. Our speed, I'm just going to put s, is distance over time. And I would just start by algebraically solving this for the distance by moving the time over to here. And my computer allows me to do this a lot neater than you folks can do with a calculator. But if you multiply both sides by t, it would look like this. Then put your time in, put your speed in, calculate a distance. Basically same thing on the right. All right, let me just keep trucking through this here. All right, number 6 here on this homework, and let me clear this up. All right, so you're looking at a bunch of graphs. I'm just going to do a quick sketch here. One of them looks like this. Another one looks virtually identical. One of them looks like this. One of them looks like this. And these are all distance versus time. These are all time. All right. So it says a car is going 18 meter per second for 14 seconds. Draw a graph that shows the distance traveled versus time for the car. So what they're basically saying is you have to pick one of these graphs. Which one represents the car? Now I'm not going to tell you which one, but you're looking for one where as time goes on, the distance should get bigger, and that will limit you down to 2 of these graphs. The next thing to do to limit it down is to figure out, which one. Well, it says that the car is going 18 meter per second. One of them should have a slope of 18 meter per second. So just check that. Once you get it narrowed down by 2 by shape, then look for the one that has a slope of 18 meter per second. All right, next one here. Okay, so now we're taking a look at number 7 on your homework. All right, and there's a graph. I'm just going to do a quick rough sketch of this graph. It looks roughly like this. Now that is a graph of distance versus time. Now, some things to realize before I even start talking about the homework. It's very important that you can interpret these graphs. This is a distance graph, right? And you'll notice that, if I pick some times like look at these times. See how as the time changes, the distance traveled not changing. So in that first region here, whatever this object is, it's not moving here. In this time frame, see how the distances on the graph, they're getting bigger, bigger, bigger. Right, so in this time frame, this thing is moving, right? Then it's not moving. Now it's moving the other way. Notice that the distances on the graph are getting smaller and smaller and smaller, and then it's not moving again. So that's a little bit about just conceptually what this thing's telling us. Now, for time A, it says represent the rise, or estimate the rise and run. Okay, so on the graph here, if you look, there's like an A here. Actually, it's over just a tad more. So they're talking about this point on the graph. And I'm not the person that developed this, but when they say estimate the rise and run, let me talk about what it is they want here. All right, so ultimately, you're going to want the slope of this line. And although it doesn't say it very well in the question, I'm pretty sure what they mean to do is you take this point and this point, and this is the rise, that distance. This distance is the run. That's what they're asking you to do there. Part B is here on the graph. I don't want to give this away, but I want you to think about that. Like if you pick this point and this point, what are you going to get for a rise and a run? Let's see. Time C is like here on the graph. And again, what they're asking you to do there, I believe, is to take this point, and this distance is your rise. This distance is your run. Now, if you back up, notice here, when we go from this point to this point, we're going right and up. However, when we go from here to here, we're going right, but we're going down, and that needs to be taken into account with your answer. So that's probably enough on this video here. I just wanted this to be some help to get you rolling on the first few problems. I think I'll make another one for the next group. Right? Have a great day.